Here's an alternate method of looking at problem 2.9. Let's look at the problem again. A stone is thrown from the top of a building with initial velocity of 20 meters per second downward. The top of the building is 60 meters above the ground. How much time elapses between the instant of release and the instant of impact with the ground? So, we draw it. We are going to throw a stone downward with initial velocity of 20 meters per second. And since that's our initial velocity direction, we'll define down as positive. That gives us acceleration of a positive 9.8 meters per second squared. And we want to find the time it takes to go to the ground. We know that our displacement is also positive downward, and that is 60 meters to the ground. And we want to find time. We solved this before, and we ended up using the quadratic formula to solve a problem that had t squared and t in it. But there's another way we could think of this. We have three kinematic variables, and we're looking for the fourth one, t. But what we could do is actually solve for the fifth kinematic variable, our final velocity, and then find time after that. It actually will make us avoid the quadratic formula. Now, we know that the ball is going to hit the ground, and some of you may say, well, the final velocity is going to be 0. Well, that's not true if we're using kinematics. I mean, the final velocity eventually will be 0 when it hits the ground, but in order to use the kinematic equations, you must have an interval where you have constant acceleration. So we can only deal with the interval of time when the ball is falling to the ground right up to the point where it's about to hit the ground. Once it hits the ground, a different force acts on the ball and the acceleration changes. So we cannot use kinematic equation once it hits the ground. We can deal with that interval as it's hitting the ground in a separate problem, but that's, like I said, a separate problem. So we can only talk about what's happening right up to the point where it's just about to touch the ground. And at that point, it'll have some kind of finite velocity. So just looking at our first three kinematic variables and our fourth one, let's use kinematic equation number 3. Final velocity squared equals initial velocity squared plus 2 times acceleration, displacement, delta y. Solve this for our final velocity. That's going to equal 20 squared plus 2 times 9.8 times 60, all that, square root. So if I take 20 squared plus 2 times 9.8 times 60, 1576 square root is 39.7 meters per second. That's how fast the stone is going right before it hits the ground. Now I know the final velocity, and I wish to find ultimately the time, so I can think of this as kinematic equation number 1. Final velocity equals initial velocity plus acceleration times time. So time will equal final minus initial velocities over acceleration. This would be 39.7 minus 20 over 9.8, everything positive, and that gives me 2.01 seconds. That's the same answer we got from a different method using the quadratic formula. It's a little bit easier here because we chose to just find more information by finding the fifth kinematic variable first and then solving from there.